Hi, and today we were going to go over scientific notation versus standard notation. This is just a quick video just to show you what scientific notation is all about, how to do it, and it should be fairly painless. So scientific notation, it's just a fancy way of saying you move the decimal point back or forth in the number in order to make the number shorter. You move the decimal point back or forth, and then you drop, whatever zeros is at the beginning or is at the end to make everything shorter. And there's a specific way to do this. Here's some examples. See, you have 6.79 times 10 to the ninth instead of 6,790,000,000 and 6.79 times 10 to the negative ninth instead of 0.000000000679. So the steps are fairly easy. When you go to write something in scientific notation from its standard form or its long form, you just move the decimal point to shorten the number. You write the newly shortened number, and you drop the zeros at the beginning or the end. You write the newly shortened number and then with a times 10 after it. And then you're going to put an exponent on that times 10. And the exponent you're going to use is however many places you moved the decimal point to shorten the number. So let me show you what I'm talking about. First, here's the number 6,789,000. First, you move the decimal point to behind the first non-zero number. So the first non-zero number in this case would be 6. And now this is an implied decimal point. There's no actual decimal point written in this number, but we can go ahead and safely assume that the decimal point is right here at the end. So what we want to do is we want to move this decimal point all the way over and move it right behind that, or right in front of that 6, or right behind that 6, depending on how you look at it. So how many places do we need to move this decimal point? We need to move it 1, 2, 3, 4, 5, 6 in order to put the decimal point right here after the 6. So we moved that decimal point 6 places. How many spaces did we move the decimal point? 6. Now we have to keep that number in the back of your mind because we're going to have to use that number here in a second. Now we've moved that decimal place up to right after the 6 here, the first non-zero digit, in the number that you come across. We're going to drop these zeros. So just cross off these zeros, these end zeros. We don't need those. And this is going to shorten 6,789,000 down to 6.789. And then we're going to add the times 10 to it. Again, we're going to drop these zeros here in a minute. We just haven't done it yet. But so if you're looking at this number going, that's long, how is that shortened? But that's why, because we just haven't dropped the zeros yet. So we have 6.789 times 10. Now, what was that number that I told you to keep in the back of your mind? The amount of decimal places we had moved the decimal point to get behind the 6. We had moved it 1, 2, 3, 4, 5, 6. Oops, sorry, messy. So we're going to take that 6, that number 6 decimal places we moved, and we're going to use that as the exponent right here on the times 10. So do you see what I did? I just put the 6, that number of of spaces we moved the decimal, and I put that as the exponent for the times 10. Now we're going to drop the zeros and rewrite it pretty. And here it is, 6.789 times 10 to the 6th. And that's how you would write 6,789,000. Now, granted, if I were to actually write out 6,789,000 it would probably take up the same amount of space as this number. But once you get into really long calculations with really long numbers and really big numbers, or really infinitesimal small numbers, they get really, really super long. And so using this technique, you can shorten some really long numbers into something manageable that you can type into your calculator. Now, exponents, that was the little 6 that I put next to the times 10 on the number that we just did. So I had the times 10 and the 6. So the 6th is what we would call the exponent. Now, how do I know if this is supposed to be a positive 6 or a negative 6? Well, if the long form number, if the standard number is more than 1, then this exponent is going to be a positive, just like it was in the example that we just did. It was positive 6. And the number, the long form number that we were working with was 6,789,000. So obviously that's more than 1. So if it's more than 1, then it's positive. The exponent is going to be positive. Now, if the long form number is less than 1, meaning that it would be 0 point and some number after a decimal, you wouldn't even have one number in the ones place, then the exponent is going to be negative, because you're going to end up moving the decimal point. When you move the decimal point in the number, you're going to end up moving it backwards. So that's when you move it back, the decimal point backwards, then you end up making the exponent negative. So let's see what I'm talking about. Let me just show you what I'm talking about. Here's a good number. Here's 0.006789. Now, this 6789, that's way less than 1. See, it's a decimal. It's got a 0 and a decimal space there, and then some zeros, and then the 6789. So that's way less than 1. So we know that this exponent, when we write the times 10, and we put an exponent on it, we know that the times 10 and times to the something is going to be a negative number. Negative n. It's going to be a negative number because of this, because of the fact that the number is smaller than 1. It's a decimal number. Now, what do we do with this decimal? Well, we're going to do the same thing. We're going to move it until you get to after the first non-zero digit. Now, the first non-zero digit in this number is, again, the 6. Because, see, anytime before you have 0, 0, 0, and then the 6. So the 6 is the first non-zero number or digit in the number. So we want to move this decimal place right after the 6, right in between the 6 and the 7. So how many places are we going to move this? We're going to move it backwards 1, 2, 3. 3 places. But we're moving it this way instead of the other way, which is what we would do if the number was over 1. Now see, we moved that decimal point and we moved it 3 spaces because the decimal point was right here. So 1, 2, 3. That's 3 spaces. So how many spaces did we move the decimal point? But wait, it's not 3. It's negative 3, right? Because we were dealing with a number that was less than 1. So it's negative 3. We moved the decimal place this way. So if you move it to the right, it's negative. The exponent's going to be negative. So how many spaces did we move the decimal point? Negative 3 spaces. So now we have the 6.789. Again, we're going to drop these zeros when we rewrite this to make it look pretty. 6.789 times 10 to the negative 3. And you just rewrite it to look pretty. You drop the zeros. See, there were zeros up here in front of the 6. We dropped those. So 6.789 times 10 to the negative 3. Now, standard notation, that's just the opposite of scientific notation. We're just going backwards, working it backwards until it gets back to its long form number, and the number in its regular form or its standard form. So pretty much the steps are just backwards of the steps to scientific notation. You move the decimal point the same number of places as that 10 times 10 exponent, and you drop the times 10 and you add zeros as placeholders. Remember we were crossing out all those zeros because we didn't need them once we moved the decimal point? Well, now when we're doing it backwards, we have to put the zeros back in so the decimal point can stay as many spaces away as it needs to. So I'll show you what I'm talking about. Here's 6.789 times 10 to the 6th. We have to move the decimal point as many places as the exponent. What's the exponent? The 6 right here, the 10 to the 6th. That's the exponent. So we need to move this decimal 6 places. 1, 2, 3. Uh-oh, I ran out of numbers. 4, 5, 6. I ran out of numbers. So that's where, when you run out of numbers and you still have to keep going with the decimal, that's where you fill in the zeros for placeholders. That's how you know where to put the zeros back, when and where to put the zeros back. And then there's the decimal right there. So how many places should this decimal be moved? 6, because the 6th is the exponent. So 6, and it's a positive 6. Notice that. There's no negative 6 up here as the exponent. It's positive 6. So they moved it. The decimal place was here after the 6, and we had to move it 6 places. 1, 2, 3, 4, 5, 6. And so there's where the new decimal is. And you added those zeros, these 3 zeros at the end here, as placeholders, because when we moved the decimal, we ran out of numbers to move the decimal around. So once again, just as a reminder, if the long form number, if the standard number is over 1, or is 1 or over, then that exponent is going to be positive. But if the standard form of the number is less than 1, if it's small, if it's a decimal number, then that exponent is going to be negative because you're going to be moving the decimal the opposite direction. So here's a negative one. Let's try this one. Now we see the exponent right here. It's negative 6. And here's 6.789. Since it's a negative exponent, we're going to move the decimal this way, since it's a negative exponent. So 1, oh, we ran out of digits. 2, 3, 4, 5, 6. And here is the new decimal. So we have to fill this in with zeros as placeholders. Sorry, I'm writing with a mouse pad. Okay, so we have 0.000006789, and then we lose this decimal is no more, and then we lose the 10 to the negative 6 because we moved the decimal. And then we just write a courtesy 0 in front of that decimal, just because it looks really funky if a number begins or ends with a decimal. You got to have a 0 on the other side of the decimal. So how many places should this decimal be moved? Negative 6. Negative 6, that's the exponent. So that means it's going to be moving backwards to return this 6.789 into its original smaller state of 0.000006789. And there it is. You filled in the placeholders, moved the decimal point from after the 6 places over here. We filled in the missing digits with zeros. And now you have this teeny tiny number, 0.000000679 or 6789. And once again, just to remind you, if the long form number is big, if the original number is over 1, then the exponents are going to be positive. If the original number is going to be small, if it's going to have zeros at the beginning of it with a decimal, then the exponent is going to be negative.